We are going to do question 30.67. Initially, the switch in the figure is in position A, and the capacitors C1 and C2 are uncharged. Then the switch is flipped to position B. Afterward, what are the charge on and the potential difference across each capacitor? We're going to start by first drawing out the circuit. And so as you can see, we have the switch, and we have A and B, and we have capacitors C1, C2, and C3. We got the battery, which is 300 volts, and we get another, the capacitor, the first capacitor is 15 microfarads, 20 microfarads, and 30 microfarads. And you can see that information right here. This is actually 15, not 150. So we should note that since capacitors C2 and C3 are not connected, that they are uncharged, as we noted right here. So right now the circuit's only like this. So while the switch is in position A, a potential difference of V1 equals 100 vectors charges the capacitors to, well, we have to use the equation Q equals CV, and so we plug in the numbers and we get 1500 Newton coulombs. And so, but when the switch is moved to position B, we must recalculate this stuff. And so we're going to do part B, which is when the switch is moved to B, wow, fail. Okay, the initial charges are redistributed, and so we're going to redraw out the graph here, or not the graph, I'm sorry, the circuit. And so once again we have, in the 300 volts, we have the capacitors, except this time B is connected. And so we should know that when the switch is placed at B, the charged capacitor C1 is connected to C1 and is connected to C2 and C3, and so C3 and C2 form equivalent capacitor C equivalent to 3, and so this will be necessary later on to know that. And so the new charge on Q1 prime goes on C1, and the charge Q equivalent to 3 goes on C equivalent to 3. The voltage across C1 and capacitor 1, capacitor equivalent to 3 is the same. And Q1 prime and plus Q equivalent to 3 is equal to 1500 microcoulomb. So having found that, oh, I'm sorry, wrong order. Okay, so using this information, we have Q1 prime. We can use the equation Q1 prime over C1 and plug in all this information, and we can figure out the charges and stuff like that. And so we can find the farads on the capacitor equivalent to 3 by doing by the inverse. You know what I mean. And so we can rewrite the equation as such, and you plug and chug in the numbers, and you find that the charge on capacitor equivalent to 3 is 0.83 microcoulombs. And so now having found out that charge equivalent Q83 is 0.83 microcoulombs, and Q2 and Q3 are 0.67 microcoulombs, we can move on to finding the change in voltages, which is part B. And so we just use the equation, the change in V is equal to Q over C, and we plug in their numbers, and that's it.